In this video, we will talk about descriptive statistics. Specifically, we'll focus on tabular and visual or graphical methods to summarize both quantitative and qualitative data. So before we get into these methods, what are these type of variables? There are two types of data sets that we'll encounter in business statistics. The first one is qualitative. Qualitative data are also called categorical data. They are describing attributes of population. For example, gender, male, female, quality, high, low, medium. Now, qualitative data can be nominal, where the labels are just descriptive. For example, if you're looking at a ticker data, we could look at various industries to which a stock belongs to. And these industries are in no particular order. They are usually ranked alphabetically, but we are not really ascribing any hierarchy between these labelings. So that's called nominal data. But in some categorical variables, the ranking may be of value. For example, if you're looking at quality, we may have low, medium, and high. For health rating as well. So in those cases, low is the first level of hierarchy, then we have medium, then we have high. So those kind of data are called ordinal data. But a more common data that we'll encounter is quantitative data. And quantitative data are always numbers. And they are a result of either counting a phenomenon or measuring an event. And quantitative data can also be discrete, where we have countable outcomes. So, for example, if we are looking at number of sodas purchased in one transaction at a convenience store, so we can count those outcomes, or they could be continuous. Continuous variables could be a result of measurement. For example, the lifespan of an engine, the blood pressure readings of a sample of population, the height and weight of a sample of population, etc. The second concept that is important in business statistics is the scales of measurement. There are four broad scales of measurement with which we get the data. The first one is the nominal scale. Again, as we mentioned, qualitative data in this example of a nominal scale, where the labels have no meaningful hierarchy. They are just identifying the elements of a characteristic. On the other hand, qualitative data can be ordinal, where we have a hierarchy and the rank makes sense. So low, medium, high in terms of quality rating. Then the third scale is the interval scale. So results like ACT score, SAT score, for example, where even though there's no meaningful zero, the difference between two observations values will make sense, is meaningful. So these are numerical data which do not have a meaningful zero, but the differences between two observations conveys an important meaning. And then the most flexible analysis can be done with ratio scale. Ratio scale is or an interval where there's a meaningful zero, and we can not just add or subtract two values, we can also divide two values, and that ratio conveys a meaning as well. So if we are looking at, for example, the weight of a can of juice, 16 ounce versus 32 ounce, we can divide 32 by 16 or 16 by 32, and we get 1:2 or 1/2:1 ratios for those juices. So ratio scale is when there's a meaningful zero, which is permissible, and we can then divide or take the ratio of the two values of that measure. So we will begin our analysis of summarizing data by looking at categorical variables. The two most frequently used tools to summarize categorical variables are frequency tables, and relative frequency is related concept, and bar charts. So we will kind of create these two and see how we can summarize categorical data. We will work with JMP to tabulate, summarize, and visualize data. So the first data set that we'll look at is a list of soft drinks, let's say vended from a vending machine. So this is a qualitative or categorical data. Here we have soft drinks being listed by their name. There's no inherent hierarchy. They're just different type of soft drinks vended from a vending machine. And in JMP, this symbol kind of tells us what kind of data JMP is importing. So if I click here, this shows me that we have nominal data. Again, nominal data is data where it is categorical, but there's no inherent hierarchy. If we had ordinal, we could have then chosen this to tell JMP that we have an ordinal data. But we're working with nominal data. Now, to start summarizing, we will use the Analyze platform. So we click on Analyze, click on Distribution, and then we can drag our brand purchase to our Y column. And we click OK. We get this bar chart. And this is in a vertical view. We can also change the view to horizontal by clicking on the menu option on the little red triangle, display options, and horizontal layout. So this is the more common way of looking at this. This tells us how many brand numbers of each brand were purchased. And next to it, we have the frequency table, where we are given the count of each of these brands. So this is called the frequency count. And on the right column is the probability. This is called the relative frequency, or the percentage count would be if you multiply it by 100, we'll get the percentage frequency. So JMP kind of provides us this quick summary of qualitative data by giving us the bar chart, which tells us visually how much of each was purchased, and then also gives us a frequency table. Now, if you wanted to add some annotations, we can go to histogram option, and then we can say show percentages. So we get now the percentage frequency. We can also show counts, but we already have counts here, so this is duplicating the effort. But again, with this menu, we can explore various options. Count or frequency. And then we have count ascending, descending. Here the default was alphabetical because C is Coke, Coke comes first, and Diet Coke, Dr. Pepper, Pepsi. But we could have also done it in ascending or descending order. Now, there is not much else that we can do with qualitative data, but when it comes to quantitative data, numbers, whether on an interval scale or a ratio scale, there's a lot more we can do. But again, we'll just, as an introductory lecture to the concept of descriptive statistics, we will just focus on tabular and graphical measures to summarize quantitative data. So we will look at 4 different things here. We'll look at, again, frequency tables for quantitative data. A related idea will be the histogram now instead of a bar chart. Then we'll look at stem and leaf plot, how to visually just get a snapshot of what the data is. Then we'll develop the idea of histograms. And then we will look at line charts for time series data. And then once we look at these measures, we will start looking at 2 variables, etc. But we'll first focus on just 1 variable. We'll begin with a very simple data series. So let's say we have data from the duration it took in terms of number of days to audit various sites. So we have 20 observations, and each row tells us the number of days it took for us to audit that site. And now, because we have quantitative data, notice that JMP now has this blue kind of a histogram bar chart kind of annotation, which tells JMP that we indeed have quantitative data. If somehow the data was nominal, where these numbers were just labels, we could tell JMP that we have nominal data instead of continuous data. So we'll begin by just creating a frequency table. A related idea then with this is the histogram as well. So we go to Analyze, and now when we click on distribution and then move our audit times to our column, we get this histogram. And again, this is in a vertical view. I can go over here and click on display options and a horizontal layout. So now this tells us how many days it took in various bins on a histogram. These are called bins. So JMP is kind of doing a default creation of the bin, but we can always change the bin width. So let's say we go to histogram options, and then we click on set bin width. Let's say we want our bin width to be 5 instead of the 2.5 that JMP did. We could have changed the setting here. Click on OK. So now this histogram tells us the frequency of each period's duration. So our first bin is 10-15 days, then 15 to 20 days, 20-25 days, and then 30-35 days as the largest one. So here we see that in the first bin, which is 10 to 15, we had 4 sites. On the other hand, in the duration, it took us from 20 to 25, we had 5 sites. So again, like before, we can now view our data as well. If we click on histogram options, say show percentages, so we see our frequency distribution here. And we can also, if you want to see counts, we can see the counts as well. Histogram options and then show counts. So now there is an additional insight that we get. So unlike in qualitative data where the ordering was chosen by default as alphabetical, or we could do ascending or descending, here now we have like a meaningful hierarchy in these orderings. So if we add up all these percentages, we will get to 100. So if I want to see how many sites or what percentage of sites it took me to do in at least 25 days, then I can then start counting the percentages from everything below this. So 20% plus 40% plus 25% would be 85%. So 85% of my sites were audited in 25 days or less. So this number is called the cumulative frequency distribution. So we can start adding up and then we get the cumulative distribution up to that point. Now this is an important concept that will be used later on when we look at more elaborate distributions. But for continuous data, not only do we have a frequency table of frequency distribution captured by a histogram here, we can also look at percentage frequencies, relative frequencies, as well as cumulative frequencies. Now, while JMP does not provide us a frequency table directly, like we got in the case of categorical data, we can create one nonetheless. There's a nice little utility in JMP which will help us do that. So once we select this column, we'll go to the column platform, click on utilities, and then here we have a couple of nice options. The option that we're interested in is make binning formula. So once I click on that, JMP has by default created this histogram for us, but it also has created this binning formula. So it has created bins of 10 to 15, 15 to 20, and so forth. And click on make formula column. So now we get these bins nicely created for us. And now how do we visualize or tabulate this? There's a really powerful utility in JMP called tabulate, which is like the pivot table function in Excel. So we have created this audit time bin. I can drag this and put it on my rows. So now we automatically get the number of counts for each row. But I can also now get percentages or relative frequency. So if we click on percentages of total, so relative frequency is essentially our number of observations in each bin divided by our total number. So we can drag this, and then notice I'm going to place it not on this, but kind of next to it, if it can let me allow. or it's not. So we can just kind of put it over here. So this gets overridden. Now we get our percentage frequency, so 20%, 40%. I can still get my n. Again, it's if I kind of move it next to it, now we get our count as well. So the ordering is a little different, but here is our frequency table where we have our frequency count as the column n. Then we have a relative frequency as this column. And again, if I add this up, I will get my total, which is 100. So get a cumulative. I can kind of add up the number to any of these. So if I want to see how many times less than 25, we can add 25%, 40%, and 20%, and we get 85, and so forth. So this is how we can really quickly get our histogram, our relative and cumulative frequencies in JMP. Now, let's see how to create a stem and leaf plot. So I'm going to go back to my data table with audit time selected. Or in fact, once we have done the distribution, if we click on the menu options, the little triangle here, we see the option of a stem and leaf plot here. So if I click here, we get a stem and leaf plot. This is again a nice visual summary, which tells us the count for each category. So the way we would interpret the stem and leaf plot is that these are our digits on the tens place, and these are the digits on the ones place. So here we have 12 and 23. That means that one of the site visits took us 12 days, and the other one took us 13 days. And then here again, because it is next to 1, then we had one for 14 days, actually 2 for 14 days, 2 for 15 days, and then we had 1 for 16, 1 for 17. And then we had 1 for 1, 2, and 3, 3 for 18 days, and then 1 for 19. So this is like a visual description. In some graphical software, we will just get 1 as the tens place, and then we will have a long column of all the unit places. In JMP, it's kind of broken down. And this is the default setting. So for example, if I look at this 27, this tells me that there was one site visit that took 27 days, and then one site visit that took 28 days. And then in the 30s, we had one site visit that took us 33 days. So this is a stem and leaf plot, where the stem is the digit in the tens place, and the leaves are the digits in the units places. And then we can just get a visual kind of feel for how the data looks like.